Hi students, welcome to Physics Truth Loka channel. Today we shall discuss one more important problem in the topic thermal properties, thermal effects of electric current. In that we are going to learn about heat produced by the combination of cells. So here the problem is like this. Here two heating coils are there. Two heating coils. They produce same amount of heat energy in 20 minutes and 60 minutes respectively, when connected to the same source. Here the important point we have to remember is same source. Both the coils are connected to the same source. Now the coils are connected in parallel. After that, first individually they are connected to the some source of voltage. Later they are connected in parallel combination to the same source. Now find the time taken by the combination of coils to produce the same amount of heat energy. So in all the cases here, when they are connected individually also, both the coils produce same amount of heat energy. Both the coils produce same amount of heat energy. So now let us go to the solution part. In the solution part, see here, to produce same amount of heat energy, this is the heating coil 1. This is heating coil 1 and heating coil 1 and heating coil heating coil 1. In this heating coil 1, it is connected to an EMF V volt, and this heating coil now takes to produce H amount of heat energy, that is H1 amount of heat energy. It has taken a time 20 minutes, and this heating coil 2 produces to produce the same, that is H2. Here in the problem H1 is equal to H2. Let us suppose H1 is equal to H, and H2 also it is given that H only in the problem. So they both are producing the same amount of heat energy, but the first coil has produced the heat energy in 20 minutes, and the second coil has produced the same amount of heat energy in 60 minutes. Now for coil 1 and coil 2, it is given that both the heat energies are same. So we know that heat energy formula V square by R1 into T1. Similarly for second coil also V square by R2 into T2, where R1 is the resistance of the first coil and R2 is the resistance of the second coil. R2 is the resistance of the second coil. And here see, if we take here in this, they are connected to the same source of supply. So here this is V square and V square gets cancelled here. So T1 by R1 is equal to T2 by R2. And it is given in the problem T1 is 20 minutes. T1 is given as 20 minutes and T2 is given as 60 minutes. So if I substitute that, minute gets cancelled, 20 by R1 is equal to 60 by R2. Now if I take R2 this side, R2 by R1 is equal to, here already 60 is there, 20 will come this side. So we can write here R2 by R1 is equal to 60 by 20, 21s, 23s, like that we can cancel. This is 21s and this is 23s. So R2 by R1 is equal to 3. If you cross multiply, then you are getting R2 is equal to 3R1. R2 is equal to 3R2. Next, now the two coils are connected in parallel to the same source. So now the coil 1 resistance is R1 and coil 2 resistance is R2. Now both are connected in parallel combination and they are again connected to the same source. This is V. They are connected to the same source V. Now R equivalent, if you find, in parallel combination R1 R2 for two resistors R1 R2 by R1 plus R2, but R2 we got it as 3R1, and if you R1 plus R2 and R2, if you add R1 plus 3R1 is equals to 4R1. R2 how you got 3R1? Now let us see R2 how you got 3R1. In this slide already we got R2 is equal to 3R1. From that we substituted R2 is equal to 3R1. Right. So here R1 again gets R1 gets cancelled. So 3R1 by 4 is the R equivalent. Next going. Now for this combination, R equivalent is, for this parallel combination of two heating coils, R equivalent is equal to 3R1 by 4. And this parallel combination is also produces the same amount of heat, and which is given by the formula V square by R equivalent into T. V square by R equivalent value 3R1 by 4. We can substitute that and we can get. Now, in the problem it is given that in the combination also individually when they are connected, all are producing same amount. This is producing the same amount of heat, and second coil is also producing the same amount of heat, and in the combination also they are producing the same amount of heat. So heat produced by the combination of parallel combination of two coils will get V square by R equivalent into T. Again V square by R equivalent into V square by R equivalent R1 into T1, V square by R2 into T2, like that we can see here V square everywhere gets cancelled. We can V square we can cancel here, or in the next step we shall cancel. So V square by R equivalent is 3R1 by 4 I root T, and V square by R1 into T1, V square by R2 T2, like that we can. Now next step, see here this 3R1 by 4 goes up, 4 by 3 V square by R1 T, V square by R1 T1, V square by 3R1 T2. So now we can cancel this V square everywhere is there, here same amount of we can cancel. So here 4T by 3R1 and T1 by R1. If I equate these two, these two, then 4T by 3R1 is equal to T1 by R. R1 also gets cancelled here. You can cancel here, R1 also cancels here. Then 4T by 3 is equal to T1, where T is the time taken by the combination of two coils to produce the same amount of heat. So we have to find T only. This 4 by 3 if it goes this side, 3 by 4 T1. And T1 is given as 20 minutes in our problem. And now 4 1s to 4 5s, you can cancel this as 4 1s to 4 5s. 4 1s to 4 5s, 3 5s are 15 minutes. So this is the answer to our problem. Thank you very much. Please like, share and subscribe. Thank you.